Welcome to the operating modes of the HT8 MCU basic tutorial. This chapter will take you to understand the operating modes of the HT8 MCU from the following three aspects: operating mode introduction, type introduction, and switching methods. Operating mode introduction. Why are there various operating modes? Present-day applications require that their microcontrollers have high performance but often still demand that they consume as little power as possible. However, the high performance often requires high-speed clocks, which will result in increased power consumption. Vice versa, the low power consumption usually uses low-speed clocks, which will result in low performance. In other words, how to balance the performance and power ratio is closely related to the use of high and low clock sources in the MCUs. Of course, there are many factors that affect the performance to power ratio, such as CPU operating status. In this situation, various operating modes came into being. According to the solution requirements, dynamic switching between modes can provide better performance to power ratio for the MCUs. The HT8 MCUs provide multiple operating modes, which can be divided into normal operation modes, idle modes, and sleep mode. The normal operation modes are divided into fast mode and slow mode. The idle modes are divided into idle 0 mode, idle 1 mode, and idle 2 mode. It should be noted that this course takes the HT66F3195 as an example, however the operating modes for different MCUs may vary. Refer to the corresponding datasheet for details. For more details, refer to the application note HT8 MCU Operating Modes Application Guidelines on the Holtec website. Operating Mode Type Introduction. These 6 operating modes have 3 key factors, which are whether the CPU is running, whether the high-frequency clock source is enabled, and whether the low-frequency clock source is enabled. Let's start with normal operation modes, which are divided into 2 types. The first is the fast mode. In this mode, the CPU runs normally. The system clock is provided by the high-frequency clock source, and the low-frequency clock source is switched on. In the fast mode, the MCU provides the highest performance and has all of its functions operational, but consuming the most power. The second is the slow mode. The CPU also runs normally. The system clock is provided by the low-frequency clock source. The high-speed oscillator can be selectively switched on or off. In the slow mode, although the performance of the MCU is reduced, it can still operate normally, and it conserves power compared with the fast mode. If it does not require high performance, the slow mode can be selected. The idle modes are divided into 3 types. In these modes, the CPU stops running, that is, the program stops execution. But both or either of the high and low speed oscillators will be turned on to provide a clock source to keep some peripheral functions operational. Users can choose whether to turn on or off the high and low frequency clock source according to the oscillator requirements for the peripherals, so as to select the corresponding idle mode. For example, most peripherals support both high and low frequency clock sources, which can be switched on or off according to the solution requirements. However, the UART interface supports only high frequency clock source. Therefore, the UART interface operates only after the high frequency clock source is enabled. These 3 idle modes have different usage and power consumption of the high and low clock sources. The last one is the sleep mode. In this mode, the CPU also stops running, as well as the high and low frequency clock sources are turned off, and the peripherals stop. The sleep mode is the most power efficient of all modes. The watchdog timer clock is sourced from the internal low-speed RC oscillator. The watchdog timer function is enabled or disabled regardless of the operating mode switching. Operating mode switching method. As we mentioned earlier, there are 2 normal operation modes, 3 idle modes, and 1 sleep mode. So how to switch between these 6 modes? First, for normal operation modes, mode switching between the fast mode and slow mode is executed using the CKS2 to CKS0 bits in the SCC register. Mode switching from the fast or slow modes to either of 3 idle modes or the sleep mode should first configure the high and low speed oscillator on or off, and then execute the halt instruction to enter the corresponding idle or sleep mode. More detailed explanation will be provided later. The 3 idle modes and the sleep mode can be switched to the fast mode or slow modes by wake-up methods. There are 4 common wake-up methods, which will be explained in other courses. Note that the idle 0, idle 1, idle 2 and sleep modes cannot be switched directly to each other. Users need to wake up the system to switch to the normal operation modes, and then switch to the corresponding idle or sleep modes. Let's first introduce the method of switching to the idle or sleep mode during the normal operation. Just mentioned, users need to configure the high or low speed oscillator on or off before executing the halt instruction. So how do we control the high or low speed oscillator on or off in the idle or sleep mode? Taking the HT66F3195 as an example, we need to first understand the FHIDEN and FSIDEN bits in the SCC register. The FHIDEN bit is used to control the high-speed oscillator on or off after the MCU enters the idle or sleep mode. The FSIDEN bit is used to control the low-speed oscillator on or off after the MCU enters the idle or sleep mode. Before entering the idle or sleep mode, we control the high and low speed oscillator to turn on or off by configuring the FHIDEN and FSIDEN bits in the SCC register. Then the corresponding idle or sleep mode can be entered after the CPU executes a halt instruction. According to the previous explanation of the high or low speed oscillator usage in the idle and sleep modes, the corresponding configuration can be made. The corresponding program examples are provided here for reference. Next, let's take a look at how to wake up from the idle or sleep mode to the normal operation mode. There are 4 common wake-up methods. 1. An external falling edge on port A. 2. A system interrupt. 3. A WDT overflow. 4. An external reset pin reset. The above wake-up methods are different and will be explained in detail in the subsequent corresponding course. Course summary. In this course, we have learned about various MCU operating modes and mode switching methods. Through the study of this course, you will have a clear understanding of the operating modes. Holtec has a professional service team to assist in development design and after-sales service. Please feel free to contact our business departments for more detailed product information and consultation services.